Again, welcome to Java Programming Language course. In this lectures, we're going to cover the basic components of Java program. This is our Unit 2 lecture. So our main objective is to become familiar with the basic components of a Java program, including methods, special symbols, and identifiers. Also, we are going to explore the primitive data types and discover how to use arithmetic operators and how to, again, evaluate arithmetic expressions. Also, we're going to explore how mixed expressions are evaluated. So first, we start with a Java program. First, we have a comment. As we said in our previous lectures, a double forward slash means a comment, or we may have a forward slash with asterisk, and an asterisk with a forward slash, which means a multiple line comment. So two double or double slash means a single line comment. So here we have a comment. Normally a comment can be the name of the author or the assignment or the date the program was written. Here our comment is explaining what the program will do. This is a simple Java program. It displays 3 lines of text, including the sum of 2 numbers. So again, in Java program, we always start with our main class. And the name of the Java file is the name of the main class .java. Again, Java program, the extension, the file name extension is .java. And here we have only a main function. So this is a very small program. And in Java standalone program or application, execution takes place in the main function. So here we have the main function, and we have system.out.println. We are going to print the string, my first Java program. ln means the cursor will move to the next line. So again, our previous lecture, we explained what system.out.println does. Also, we have system.out.print. Print means we print whatever in the method argument, whether a string or a value, then the cursor will be in the same line. ln means the cursor will move to the next line. So we can see our output here. We have my first Java program. Then the second print statement will print in a second line because print ln, the cursor moves to the next line. So here we have plus here. This plus is working as a join operator or to concatenate. So here we are going to have the sum of 2 and 3 equal to 5. So we use the plus to join. And here also, the plus we are using here is a string because we have 7 plus 8 in a double quotation. So everything here in double quotation is a string. The next plus sign acts as a concatenate or join operator. Then the second plus sign had as arithmetic operator. So here our output will be 7 plus 8 equal to 15 because 7 plus 8 here is 15. And in our first lectures, we said that the plus, if we have a string at the left side and the right side of the plus sign, it will act as a join operator. It will join the 2 strings together. Or if we have only one string at the left side and the right side is a value, or a value at the right side, and then the left side is a string, or the left side is a value, the right side is a string. It's also going to join the string and the value. But if we have both sides as a value, in this case, we have 7 and 8, both of them are value. The plus sign will add as an arithmetic operator. So here is acting as an arithmetic operator. So that's why our output is 15. So now we shall go through the basics of a Java program. First, a Java program is a collection of classes. A classes normally consists of data members and also the methods. So the data members will be the variables, the data we need, and the methods will be the operations, for example, a function to execute a task. So there's always a main method in every Java application program. In this course here, we are going to focus on Java application program. We also have a Java applet. In Java applet, we don't need a main method. We have a Java servlet. Also, we don't need a main method. But this is a Java application program. So always a main method is needed to, again, execute our statement. So every statement or every expression is executed in a main method. So the term token is the smallest individual unit of a program. And we shall see a few examples here. So these are special symbols. They can also be called a token. We have addition, minus, multiplication, division. We have a period, semicolon. We have a question mark. We also have a comma, and then relational operators greater than, equal, equal, not equal, and less than or equal. And we shall go through all these special symbols as time goes on. We also have a Java have what we call the reserved words, which is also called the keywords. These are special words that, again, Java understand. So for example, if I create a method and I name it public with all the characters are lowercase, I will get an error. Or if I declare a variable and I name it public, or I create a main class and I name it public, I will get an error. But if I name it public and let's say the P is uppercase, that's fine. Again, Java is case sensitive, so lowercase and uppercase are different. So if I have, let's say, a word public, start with uppercase P and another one lowercase p, the two are not the same. And we shall go through most of the special symbols and also the reserved words or the keywords. And next we go through what we call the Java identifiers. Java identifiers are the name of things. Example will be the name of a variable, the class, methods, functions. They are all called identifiers. So here we say name of a things consists of letters, digits, the underscore, character, and also the $sign. So the name of a class and also the name of a method or any Java identifiers must use only a variable. These are only, for example, we cannot use any other symbol such as question mark or comma or space. We can only use letters. The letters can be uppercase or lowercase. We can also use digits. We can use underscore, and that's the only special symbol, underscore, character, and also the $sign. And also the name of the identifiers cannot start with digits. So we can start with letters, underscore, character, or $sign. Cannot start with digits. So here we say must begin with a letter, underscore, or the $sign. That's the name of Java things, the Java identifiers. So this is an example of some few illegal identifiers. Here we have employee salary. Yes, this is wrong because there's a space between the two words. Here we say there can be no space between employee and salary. So instead of space, we can have underscore. The second one, we have the LO with exclamation point. Again, we can't use the symbol exclamation mark. Cannot be used in an identifier. Again, we cannot use the exclamation mark in any Java identifier. Also, the same thing applies here. We have 1 plus 2. We cannot use the symbol plus or addition. The symbol plus cannot be used in identifier. And the last one is second. The same thing is illegal because we cannot start with a digit. An identifier cannot begin with a digit. Next, we move to the data types. In this lectures, we're going to discuss about the primitive data types. We also have classes, which is the reference data type with objects. We start with the primitive data type. So a data type will be a set of values together with a set of operations. So example is an integer, which is a data type that deals with integers or numbers without a decimal part. So an integer will be a whole numbers. And normally we use the term int or integers. We also have a floating point, which will be decimal values. So which is a data type that deals with decimal numbers. And we also have the Boolean data type, and that deal with logical values, and only two, either true or false. So these are the char means a character. These are the integer data types, char, character, byte also the same. And we know the size of a byte is 8 bits. We also have short, int, and long. Now, int and long, we can use it as a whole numbers, but the difference is the size of the value. Long is larger than int. And we shall go through that in a second here. So we can see the data type char. The storage capacity is only 2 bytes, which is 16 bits. And also data type byte will be only 1 byte, 8 bits. The short is only 2 bytes also, 16 bits. But we can say int is 4 bytes, which is 32 bits. And long, which is the largest, is 8 bytes, which is 64 bits. And we can see the values from -2 to the power 63 all the way to +2 to the power 63 minus 1. So that's a lot of values in trillions. And so primitive data type, as we said, we have a floating point data type also. So first we went through the integer. And the floating point data type, we have 2 types, the float and double. Now the size depends on the precision. Precision is the number of decimal places. So for example, float can have 6 or 7 decimal places. And the data type double can have up to 15 decimal places. We also have the Boolean data type. It's only 2 values. So it's a logical values, either true or false. So here we said the literals or integer constants or integers can be 23 and -67. And this is again integers or the whole numbers. A floating point, an example, we can have 12.34 or 25.60. So again, an integer is a whole number without a decimal place. It can be a positive value such as 23, or it can be a negative value such as -67. Same thing applies to floating point decimal numbers. It can also be a negative value, but you have to have a decimal places. Here we have 2 decimal places. Also the character literals, and normally a character also can be a digit or letters, but characters always have to be in a single quote. So if I have 5 without a single quote, then it's an integer. With single quote means it's a character. With double quotation means it's a string. A string is not a primitive type, so we will discuss that later on. Next, we go through the Java arithmetic operations and the operators, and also the operator precedence. So we have 5 arithmetic operators in Java. This is addition, subtraction, multiplication, division, and modulus. We know the first 4, but the last one, modulus, we don't use this much in mathematics. But what modulus gave us is that when we divide 2 values, the remainder will be the answer. So for example, 10 divided by 5, the answer is 2, division. Now 10 modulus 5, the answer will be 0, because if I divide 10 by 5, the remainder is 0. The same thing applies, 10 divided by 6, the answer will be 1, remainder 4. So 10 modulo 6, the answer will be 4, the remainder. Also, we have a unary operator that has only one operand. And we know all these 5 arithmetic operators, they are binary operators because we need a value on the left side and the right side. For example, to add values, at least I need 2 values to add. To find a difference, to use the subtraction, I need 2 values, at least minimum of 2 values. Same thing applies to multiplication, division. Modulus also the same thing. I need 2 values to find the modulus of the 2 values. So unary operator, we also have the binary operators. So as we said, the arithmetic operators are binary operators. Example of a unary operator can be the increment operator, which is plus plus 3, we increment by 1, and we will discuss that. So next we go through the order of precedence, which is the same as arithmetic, basic arithmetic. So we know the order of precedence. And normally we always start with parentheses, then the exponent, then with the arithmetic operations, multiplication, division, and modulus will be in the same precedence from left to right. Then addition and subtraction will be next. So here we see operators in 1, the first have the higher precedence than the operators in the second. So multiplication, division, and modulus have higher precedence than addition and subtraction. Now, when operators have the same level of precedence, then we say that operations are performed from left to right. So if I have arithmetic expression with multiplication and division, then the one that comes first from left will be executed first. So the operation will be, but if I have multiplication and addition, it doesn't matter, multiplication can be on the left side or the right side. They have to be executed first before addition or subtraction. So next, we talk about the expressions. We have the integral expressions. Integral expressions, we know the integral data type means a whole number. So that will be expression with whole numbers. Floating point will be decimal expressions. Sometimes we may have a mixed expressions, which means we have both a whole numbers and decimal numbers together. So let's see an example here. So for example, we have 2 plus 3 times 5. This means we are going to multiply 3 by 5 first because multiplication have higher precedence than addition. So 3 times 5 is 15 plus 2, 17. Here we have 3 plus x minus y divided by 7. So we have to know the value of x and y in order to execute this expression. Same thing applies to the third. We have x plus 2 times y minus z. By y minus z is in the parentheses. So minus will execute first because parentheses execute before multiplication and divisions, etc. So parentheses will execute first. When we get the answer, we do multiplication, then we do addition from left to right. We also have a floating point expression, which means all the values will be decimal values. 12.8 times 17.5 minus 35.50. So multiplication will be done first before subtraction. Same thing here, we have 2 variables, x and y. So if we know these 2 variables, we can again find the expression. Again, multiplication first, then the addition, then the subtraction. We also have a mixed expression, which means we have both a whole number and also a decimal number. So we have the integer and the floating. And here also we can find the solution will be 5.5. Here also we have 6 divided by 4 plus 3.9. Now, when you have an expression, a floating and an integer, our answer will be floating answer or decimal. So here we say the integer operands yield an integer result. Floating point numbers yield a floating point result. But if we have both types operands are present, then the answer will be a floating point. So what we mean to say is that if our expression, all the values are a whole number, then the answer will be a whole number. If all the values are decimal numbers, then the answer will be decimal number. But if the expressions or the values are mixed, we have a whole number and we have decimal number, the answer will always be a decimal number. Again, floating point means decimal number. Then integer means a whole number. So we have different types of conversion, which also we use the term casting. Casting or conversion means we can change one data type to another. For example, we can change the data type int to double, or from double to int, or long to any type. Now, the main reason why we do this is depends on if we are doing some calculations and we want to keep our decimal number. Because if we divide, let's say we divide 10 by 6. 6 is a whole number, 10 is a whole number. We are going to lose the decimal part because there are two integer values. So the answer will be integer, a whole number. So because of that, if we like, we can convert or cast the int, one of the int value to decimal or a floating point. So if I have 10.0 divided by 6, my answer will be 1 point, the rest. So I'll get the decimal answers. So how do we cast or convert data type? We may have the data type that we are converting and the expression. So again, the syntax is data type name and the expression. So example given, for example, I have 7.9 plus 6.7. Actually, the answer here will be 14.6. But when I get 14.6, I convert it to int. So I'm going to remove the decimal values. So the answer will be 14. Or we can convert int 7.9. Now, if I convert 7.9 to int, I will lose the decimal, so I'll get only 7. If I convert 6.7 to int, I will lose the decimal, so I'll get only 6. Now we have two int values, so 7 plus 6 will give me 13. So we can see the same two values. When we combine the two values together, we get a decimal value. Then we convert into int to give us 14. But if we convert each value to a whole number first, we get only 7 and 6. So 7 plus 6 will give us 13. So next we talk about the class string. As we said earlier, again, a string data type is not a primitive. A string data type, Java have the class string, a predefined methods that comes with it. So we can use it to manipulate the strings. So class strings is normally used to manipulate string. For example, if I have a string and the cases are lowercase, I can use a method called to uppercase to convert it from lowercase to uppercase. I can use a method called length to get the size of the string. The size of the string will give me the number of characters or symbols that the string consists of. So here we say a string is normally a sequence of 0 or more characters. Zeros means empty string. We just have only the double quotation, nothing inside. So the string, we always enclose it in a double quotation marks. We can have null or empty string. So as we said, the sequence of 0 means there's nothing, empty strings. Then a numeric string consists of integers or decimal values. As we said with the character, excuse me, if I have 5 and it's in a single quote, it's a character, it's not a value. So the same thing if we have a value, let's say 5 or 100, any value, if it's in double quotation, it's a string, it's not a value. With character type, we have to use only one because the size is only 1 byte. So we have to use either 1 digit or a character or 1 symbol. But with string, Again, we can have as many characters as we want. So 53 is not a character because we have 5 and 3. But if I put 53 in double quotation, it's a string. If I put 53 in a single quote and assign to a variable type character, I will get an error because it's too big. So the length is, again, the number of characters in a string. And we saw the operator plus. So operator plus can be used to join two strings or a string and a numeric value or character. So we saw our previous example, but this is another example, the sum equal to plus. So here we can see it's in double, the sum equal is in double quotation. So that's a string. Now to my right, I have values, but because my left, I have a string, this plus may act as a join operator, which we call the concatenate operator also. So the output will be the sum equal to 12, 26. We join the 12 and 26 together. Now we should consider the following now. So here you can see that we put it in a 12 and 26 in a parenthesis and a plus. So that means to the left of the plus sign here is a value 12. To the right is a value 26. So here the plus here will act as addition. So if we do this, we are going to get, in this statement, we say because the parenthesis, you first evaluate the parenthesis. So we are going to get 38. 12 plus 26 is 38. So our answer will be the sum equal to 38 instead of the sum equal to 1226, because this is a parenthesis. So the parenthesis will execute first, which make the plus to the left is a value, to the right is a value. So in Java also, we can get an input to perform any operations. Two ways we can get an input. Either we can use assignment operator or we can use the scanner class. And there are two types of input. We can have a constant input. So here we say a name constant. In this case, we have to declare the variable constant using the keyword funner. And a constant means the value cannot be changed during the program execution. And anytime we declare a constant value or a variable constant, we are going to declare it by using the reserved word funner. Then we have to initialize it. So anytime you declare variable constant, we need to initialize it. So this is an example. We have a variable named centimeters per inch. Now you can see there's no space between the words. So we use underscore, the goal, so that we can be able to read it. It's more readable. The data type is double, which means centimeters per inch variable only takes a decimal value. We declare it as a constant variable, so we use the keyword funner. So first, if you are declaring a constant variable, we start with the keyword funner, the data type of the variable name. Then we have to initialize it. Since it's a constant variable, we have to provide the value that it holds as constant. So this variable centimeters per inch, the constant value is 2.54. Another example, funner, the data type for the variable is int, and the variable name is number of students, and we have it as 20. So the variable number of students is a constant variable, and the value is always 20. So we cannot change this value during the program execution. We can also have a constant variable, data type char. The name of the variable is blank, and it can be, since we have single quote, it's a character. There's nothing means empty character. Then we have another one, funner, double. The name of the variable is pay rate, and we assign 15.75. Again, always we have to initialize a constant variable. So we can see all the 4 examples here. we initialize it. Now, if it's a regular variable, we don't need to initialize. So a regular variable, always we consider the name, the value that they have, the data type. The data type tells us the size. The size will tell us how large the value the variable can hold. So if I have a variable, I know it will hold a very large value and it's a whole number, I may use long. If I know the decimal number and the decimal place can be as much as I want, I may use, instead of using float, I may use double. So here we say variable content may change during program execution. So this means if we declare variable, we don't need to use the keyword fana. The keyword fana is for a variable constant. So during program execution, the value does not change. By regular variable, the value can change. Also, we must declare before it can be used. In Java, we always declare variable before we use it, and may not be automatically initialized. Constant variable must be initialized because that will be the constant value. But a regular variable, we don't need to initialize it when we declare it. Now, if a new value is assigned, we are going to overwrite it with the old one. So the old one is destroyed. Also, value can only be changed by an assignment statement or an input read statement, example used in the scanner class. So let's see example. We can see a variable name amount due. The data type is double, which means it's a decimal value, but we didn't initialize it. Again, only constant variable, we have to use the keyword fana and we have to initialize it. Another example, we have a variable name counter. The data type is int. Another variable name char, ch, data type char. Now, if I have two variables and the data type is the same, I can declare it and have a comment space between them. So for example, I say int counter 1, comma, space counter 2, which means I have two variables, counter 1, counter 2, and they are all data type int. I can declare them separately or declare them once all together. Just make sure we have comma and space between the variables. And this is the example. So int num1, comma, space num2, which means we declare two variables and their data type is int. We can also use the assignment operator to assign a value as we saw it in a constant variable. So the syntax is the expression, we assign it to the variable. So the variable is like the memory location. Whatever the expression I have, whether a value or formula, I'm going to store it in a variable. So this example, we have num1, num2, cell, first string, and str. Now we can assign values to them, or also we can declare and assign the value at the same time, like how we did with the constant variable. So I can have int num1 equal to 4, or just int num1, then next line num1 equal to 4. So the equal sign here is called the assignment operator. Everything on the left side are assigned to the variable on the left. Everything on the right side is assigned to the variables on the left. So remember, first variable is char. So we assign character D. We have to be careful. So if I assign only D or 4 to first, I may have error because the data type is char. I need to assign and store value char to it. Value type char. So this is another example. As we said, we assign 18 to num1. Now they tell us what to be the answer here. We are adding 18 plus 27. So our answer here will be 45. So num1 will be 45 now. We assign num1 to num2, so num2 also become 45. So which means num1 is 45, num2 is 45. Now we divide num2 by 5, so that will give us 9. So num3 will be 9. Then we divide 9 by 4, and that will give us 2. So num3 will be 2 now instead of 9. So let's say this is the steps. First, we have the 3 variables. Our first statement, we assign 18 to num1. So as we said, variables are memory locations. So we assume the boxes here are the memory location for num1, num2, num3 variable. So since we assign 18 to num1, 18, num1 is 18. Next, we say num1 plus 27, and we assign it back to num1. So that will be 45. Then next, we assign num1 to num2. Num1 is 45, so num2 also will be 45. So we have 45 and 45. Then we say num2 divided by 5, we assign to num3. So num2 is 45. 45 divided by 5 will give us 9. Then we know num3 is 9. 9 divided by 4, again, this is 9 is an int, value 4 is an int. So we are going to lose the decimal part. So our answer will be only 2. So that will be at the end here, num1 is 45, num2 is 45, num3 is 2. Now next, if we want to get an input, instead of using the assignment operator, we can tell the user either to use the keyboard to enter an input or get the input from a file system. So doing that, we're going to use what we call the standard input stream object called the system.in. Remember, when we want to print an output on the screen, we use system.out with the print or println statement. Now, if I want to get input from a user, I will use system.in. If I want to print on my screen, I will use system.out, then the print method. So input numeric data to program, we can separate by blanks or lines or tags. So for example, if I have 2 values, 45, and I want to store 4 in variable 1, 5 in variable 1. If I enter 4 and 5 at the same time, the value will be 45 and everything will go to variable 1. But if I want only 4 in variable 1, 5 in variable 2, then I'm going to, when I enter 4, either I will press the enter key or space bar. I can have a line, blanks, then I enter the second value. Now to read data, we create an input stream object of the crash scanner. So if we want to read the data, that means from an example would be a keyboard. We are going to start with keyboard. First, I'm going to create a scanner object. Then after that, I can use the methods such as next line if the data type is string that I'm going to enter, or the variable that I'm going to put the data in is a string. Now, if the value is int, then I'll use next int method. If the value is decimal value, I'll use next double. So it depends on the data type. Again, we are going to see example in the program soon. So first we create our class object. Then we use the class object with the, depends on the data type, either next line, next int, or next double to get the input from the keyboard. So this is the example. We start with static scanner console equal to new scanner system.in. We create a scanner object called console. That's the first thing we need to do, console. Then the next step, we are, for example, we declare 2 variables, feet and inches. So we create our objects, scanner object console. Then we want to get an input into feet and inches. So here we say, suppose that the input is 23 and 7. So 23 will go to feet, 7 will go to inches. Then what we're going to do, we are going to, since 23 and 7 are integers or a whole number, we are going to use the next int. So we use the scanner object console.nextInt, and this will allow us to use our keyboard to enter 23 into feet. And the next one, also the same thing, console.nextInt. We enter the 7 into inches variable. Now, in order for this to work, we can see there's a space between 23 and 7, which means we have to When we enter 23, we press the space bar or enter key. Most of the time, we use enter key, then you press the 7. So those are the steps to get an input instead of using the assignment operator. If you want to get the input from the keyboard, first we use the scanner class. In order to use the scanner class, we are going to import a package called utility package. So it will be import.java.util.scanner, then semicolon. And we will discuss about that when we do a lab work. We also have the unary operator called the increment. So plus plus means we are going to increment the value by 1. Increment the value of its operand by 1. So if I say plus plus 5, it means 6. Or if the variable have a value, let's say we have a variable named num, and the value is 10, and we say plus plus num, it will increase it to 11. We also have the decrement operator that will decrease the value by 1. So example given, we have 2 types, pre-increment, which means we have to increment first, then we store it, the variable. Post-increment means we do something with the variable first before we increment. Pre-decrement means we decrement the value of the variable first, then we use it. Post-decrement means we use the variable for something first before we decrement it. And we shall see examples soon. And we already went through output in our first lecture. So if I want to output something on my screen, I will use the system.out, then either print or println. So this is the syntax, system.out.print. .print means whatever we print in the argument here, the cursor will stay in the same line. Println means the cursor will move to the next line. Or if I want to print an empty line, just leave a line space between my output, I will just have system.out.println and nothing. So that will just give us an empty line. And also in Java, we always have what we call the escape sequences. It's very important. For example, if I need a new line, I can use the \n. Here, the cursor moves to the beginning of next line. \t is for tab. The cursor moves to the next tab stop. \b is a backspace. So cursor moves 1 space to the left back. And also \r means the returning. So the cursor moves to the beginning of the current line. It doesn't move. So if the cursor is in the middle of a line, it will not move to the next line, but rather to go back to the beginning. So that's why it's called return. Now, if I want to print a \, since \/ is part of escape sequence, I have to have double \. Then 1 \/ should be printed. The same thing, if I want to print single quotation, since we know in character data type we use single quote, we also have to use the \. So if we say \/ and single quote, it means we want to print it. Same thing with the double quotation. \/ double quotation means we want to print the double quotation. If we don't have the \, Java will think that the double quotation means the beginning of a string, or single quotation means beginning of a character. So we need the \/ to print. So we talk about importation of packages. So Java comes with packages, and packages normally consist of classes. And classes, as we know, consist of methods. And normally, if we want to use any class in a specific package, like I want to use the scanner class so I can get input from the user, then I'm going to use utility package. So I have to have import.java.util.scanner. So a package is a collection of related classes. And a classes also consists of methods. And methods are normally designed to accomplish a specific task. So method consists of a group of statements, expressions to, again, perform specific tasks. For example, we can write a method to find a sum of 2 numbers. Now, how do we use the import? We use the keyword import. So to import component of package into a program. So import is again a reserved word or keyword. So example here, we say import java.io. Asterisk means you want to import all the classes in the package. Here the package is IO, input and output. So for example, if I want to use files in my program, let's say get an input from a file or store my program results into a file, and I need to do some file operations, open the file, closing the file, etc. Then I need IO, the input output file. So a series here means again, I'm getting all the classes, importing all the classes in the IO. So import the component of this package, java.io, into the program. Primitive data types and the class string. Also, so part of the Java language, and also don't need to be imported. So when you run your, if I use system.out.println, I don't need to import anything because it's part of the Java language, which is the Java package called .lang. Import java.lang, we normally don't import, which is the Java language. So this is a syntax of a class. We have the keyword public class and the class name and the class members. The class members can be the values, the data members, and also the methods. Also the syntax of the main method may consist of as many statements as we want, depends on the tasks we want the program to do. So we have public, static, void, main, string, argument. Always the main method arguments, string, array, argument. Why static? We may discuss this more detail. A static method means the method doesn't depend on any class or object. So I don't need to create an object before I use the method. Public means for security, public is, and the class here can be, or the method here can be used by any class in the program. So that's why main method is always public, because anything we do, if we create any class, any object, if we want to do any, actually, if we create a class, if we want to create the object of that class, we have to do it in the main method. So execution takes place in the main method. So this is some few examples on assignment statement. For example, we have variable equal to variable times expression, which means whatever the variable times expression, the result will be stored into a variable. This is also equivalent to writing variable multiply equal to expression, because the variable name here is the same as the variable here. Same thing with addition. I have a variable old content. I will do it, I'll add it to an expression, then I'll give the result back to the same variable. So I can write it as variable plus equal expression. So again, that will be the conclusion of our lectures. In these lectures, we try to understand the basic concept of Java elements or components, and we didn't do much lab work. So in our next lectures, we would do more lab work. So again, wish everybody the best, and thank you.